All right, welcome back to some more Explore More today. So today we're going to explore more about solving systems of equations. If you watched the last video, we used a method called substitution. Today we're going to learn a second method called elimination. Okay, so elimination, if you take a look at this, if you try to use substitution to solve this system, it could work. We could definitely use substitution to solve this system of equations. The problem would be, because these coefficients are not 1, the solving part of it would be a little bit more complex. Okay, so we're going to use a different strategy called elimination today, and it kind of speeds up this process when the numbers work out a little bit nicer. Okay, so if you notice, the first thing we see is the first equation has a 4x in it, and the second equation has a negative 4x in it. Those are opposites of each other. So the way this strategy of elimination works is we're actually going to add these two equations together. So we're just going to treat this like a big additions problem. So if we look at this, so if we do 4x plus negative 4x, those just cancel out. That's just 0. And then we have 8y plus 2y. That's 10y. And then 20 plus negative 30 is negative 10. So when we use this elimination strategy, it gives us a way to eliminate the x variable from this equation. Okay, now that only works because they are perfect opposites of each other, right? 4x and negative 4x. And then everything else we just added together. But now we have this nice simple equation, 10y equals negative 10. If we divide both sides by 10, we get y equals negative 1. And then just like we did in the last video, if y is equal to negative 1, now we can take this negative 1, we can plug it back into either of our equations. I'll just use the first one here. So this would be 4x plus 8 times negative 1 equals 20. 8 times negative 1, that's negative 8, so we could add 8 to both sides. So 4x equals 28. Divided by 4, we get x equals 7. So the solution to this system of equations would be the point 7, negative 1. Okay, so let's recap. We were able to add these equations together, which canceled out the x's, which made this equation much simpler to solve. Now, I chose a very friendly example to start with. Let's look at an example that maybe the numbers aren't quite so friendly. All right, so here's a second systems problem, but you can see none of the numbers match up perfectly this time. So we can't just add them straight away. We got to think about something we could do first to kind of make the values a little bit more friendly. So what we can do, if you look at this second equation, we have negative 8x minus 6y equals 6. If we double all of these values, if we multiply them all by 2 times 2 on everything, then this equation would turn into negative 16x minus 12y equals 12. Okay, so we're allowed to multiply everything by 2 as long as we do the same thing to both sides. That's not changing any of the final outcomes, any of the final values of this. It's just giving us a better starting point. And so now when we do that, we see that we have a positive 16x in the first equation and a negative 16x in the second equation. So now we can just add these together like we did in the last example. So 16x minus 16x, those cancel out. Negative 10y plus a negative 12y, that would be negative 22y. And then 10 plus 12 is 22. And so we can solve this equation now, divide both sides by negative 22, and we get y equals negative 1. And then once we do that, we take this negative 1, we plug it back into the original equation for the y value. So this would be 16x minus 10 times negative 1 equals 10. So negative 16x plus 10 equals 10. Subtract 10 from both sides. So this would give us negative 16x equals 0. And then divide by negative 16 and we get x equals 0. So the solution to this one would be the point 0, comma, negative 1. Okay, so that one, just one extra step here. We had to find a way for these values to line up, and then we could subtract them or add them in this case and use our elimination. All right, so this will be the last example we look at here. So if you take a look here, there's no values that match up right away. 3x and 5x, 2y and 5y, those don't match up. And because 5 and 3 and 2, there's no multiple that takes 3 directly to 5 or 2 directly to 5. It's a little bit harder to figure out what should I multiply these by. So in cases like this, we actually are going to multiply both equations by a value. Doesn't have to be the same value with both equations. But remember, our goal is to get some of these values to match up, some of them to be the same. And so we could probably be clever here and think about some different values that we could use. But a simple way that'll always work is we can multiply this first equation by 5, meaning the coefficient from the bottom equation, and then multiply this second equation by 3 using the coefficient from our first equation. And that's gonna make sure that after I do this multiplication, these equations will line up and there'll be something that we can cancel. Okay, so we have 5 times 3x, so that'd be 15x. 5 times negative 2y is negative 10y, and 2 times 5 would be 10. So that's what the first equation turns into. And then the second equation, 3 times 5 is 15x. 3 times negative 5 is negative 15. And 3 times 10 would be 30. Okay? Now, if you notice, this equation also, this system is a little bit different than the other ones that we use because we have 15x for both of these, which means I can't add them together in order for them to cancel out. Now I really need to subtract these two equations. Okay? So when I subtract these two, no problem on the front end, 15 minus 15, those cancel out. But what I really need to be careful about is that I'm subtracting the rest of these also, meaning I need to do negative 10y minus negative 15y. Okay, so that's where a lot of times we forget that negative. Some people like to distribute that negative through all the way. We could have even multiplied this equation by negative 3 up at the beginning to get those to be opposites. As long as we're careful, either way will be just fine. So I'm going to do negative 10 minus negative 15, which would be a positive 5y, and then 10 minus 30, which would be negative 20. So then when I divide by 5, I get y equals negative 4. So now I have the y value that will be in our solution, and then we can plug that into either of these originals. I'll plug it into the first one. So 3x minus 2 times negative 4 equals 2. 3x. So negative 2 times negative 4 is 8. So we'll do minus 8 from both sides. So 3x equals negative 6. Divided by 3, we get x equals negative 2. So the solution to this system is the point negative 2, comma, negative 4. All right, so that's elimination. So elimination is one of my favorite methods. It takes a little bit of thinking on the front end, but a little less algebra than substitution. So good luck with your problems today. Let your teacher know if you need any help.